Thank you for being here. So today I'm going to present a paper that looks at bundling demand. In this paper, basically, we sort of see what happens if we sort of aggregate demand. And to look at that, we are looking at the broadband need for schools. So schools need internet, they need broadband services. So they sort of the ISPs or the internet providers supply broadband services to the schools. And we look at what happens if instead of just a single school asking the internet provider for a price, what happens if we combine these schools? So that's the basic idea in this paper. Okay, so just a bit of background. Providing internet to schools is an important issue policy-wise. At Fed level, there is a subsidy known as the E-rate subsidy. Let me just put this on the side so that E-rate subsidy, which is provided by the Fed, and it basically says that as long as the schools are doing a comparative bidding and they're asking for prices from all the internet providers, they will get from 20 to 90% subsidy, depending on their need, location, where they're located, and other characteristics. And there's about like 4.75 billion that is the funding for this subsidy. So a lot of money is sort of spent to see whether schools can be provided with internet, with high quality internet, right? What we're going to look at in this paper is another way, instead of subsidy, is if we sort of, as I said, bundle the demand of schools. So this was done by the New Jersey state government. What they did is that they divided the New Jersey state into 4 different regions, and they sort of asked the schools if they want to be part of these consortiums, and these consortiums would then ask the internet providers to give them a price for all the schools, right? So what's happening is if I'm an internet provider, now I'm looking at serving a full region. The advantage of that is that if I'm serving a full region, there is some sort of cost complementarities that would come about rather than just a school asking me whether I can provide there or not. So that's the basic idea. This is just the glimpse of the results. What we see is that there was a price decrease. And in fact, on top of that, bandwidth, which is also an indication for the quality of the product, also increased. So schools now demanded higher bandwidth, got better quality internet after the consortium was formed. And overall, the impact in the counterfactual when we calculate is sort of equivalent to the subsidy program, right? Without actually spending the money that is spent through the subsidy program. Okay, so this is just a list of literature that this paper is related to. I'm happy to talk about this paper offline, but in interest of time, I'm going to move on. So a bit more about how New Jersey executed this plan. They asked all the schools for their demand. So that included not just, okay, you need internet, how much bandwidth do you need, how many buildings do you have, so on and so forth. They combined all of this demand, and then they asked the internet providers, the ISPs, to sort of bid on that. So the ISP sort of gave prices or the bids per school, but the consortium or the winner was decided on the aggregate basis, right? So the best price on average would win the auction. There were different categories. There were categories depending on whether you look at WAN, broadband, or direct internet services. So this gets more technical, but basically we have sort of a multiple category data here. Okay. Now, why do we think that there might be a decrease in price? There are 2 sort of effects that we think are happening here. First is the consortium or the bundling of these schools' demand is solving the exposure problem. And the idea is, okay, if I'm an internet provider, I will only give a good price to school 1 if I know the neighboring schools are also going to, sort of take internet from me, right? But that's happening simultaneously, so you don't know which all schools will actually be in your network. This is solved when you have a consortium because then you know how many schools you're serving. So there is a decrease in cost that happens when you serve more schools within one region. And the second effect is the competition effect. The competition effect is basically coming from the entry. So knowing that I will get a bunch of these schools in a specific region, internet provider that was not present in that region might still bid on the bundled schools, right? So they might think, okay, now the demand is big enough for me to cover the infrastructure cost and I might enter this market, right? So there is an entry effect and there is a cost complementarity effect. Okay, so this is the basic statistics of the data, how the data looks like. As you can see, if you compare the participant and the non-participating schools, there is a decrease in price, right? Which is more than the decrease in the price for the non-participating schools. And you see the same thing in the bandwidth. Apart from that, we also see a bit of increase in fiber. So that means that there was more infrastructure that was sort of laid down from 2014 to 2015. And there was a bit of increase in the HHI, which says that, okay, one sort of internet provider is now serving more schools. Right, so that's sort of the basic data that we see. Okay. So currently what we're doing is a basic event study. We're doing a difference in difference approach, looking from 2014 to 2015. So just a pre and post analysis. And what we want to capture is what is the effect difference between participating and non-participating schools. And I said, we see a significant effect on price as well as a significant effect on bandwidth. So both price and bandwidth decreased after the consortium was formed. And this is true even when we include more controls. Okay. Now, since this was a sort of a basic pre and post, we might think that the parallel trend assumption might not hold. So we did analysis to look at the sensitivity to this parallel trend assumption. So suppose that the participating and the non-participating schools were actually having different trends, then how much would our result be affected, right? And this graph shows, this is basically the price effect, and the price effect becomes sort of insignificant if the difference in the trend is 2 times. So the participating schools have, the non-participating schools have more steeper decrease than the participating one, right? So then the price effect will sort of go away if the difference in the trend is 2 times, right? Now, even though this looks like the price effect goes away, the idea here is since the price is given by internet provider and these broadband prices are specific to location, we don't expect that the trend in price would be so different between the two unless it is sort of obviously related to the consortium, right? So that's sort of the justification. Another sort of positive effect here is the bandwidth effect doesn't seem to go away. Right? So the quality of the product definitely increased, even if we think that the trends are drastically different between participating and non-participating schools. Okay, we did some robust check according to what would be the controls, since we're looking at location-specific prices here. Some schools who did not participate might also be affected by the cost complementarity. So we sort of checked for that to look at the robust check. And the effect is robust to all those different, how we define the control group. Okay. Now, to look at basically from these results, to look at the change in welfare, that will help us compare how does bundling the schools relate to giving subsidy to the schools. We did a change in welfare. Of course, to look at the change in welfare, we would need the full demand function, which is not possible here. So we looked at another approach that was suggested by Kang Eversman, which says that you want to sort of bound the welfare if we know the pre and post quantity and price. So that's what we sort of use to analyze that. And we do see that the welfare effect is more for the participating schools versus non-participating schools. And then if in terms of percentage, we compare that even on a lower bound, the gain from consortium was about 66% of how much the gain is there from the subsidy. Right, so that's sort of the comparison between the bundling and the consortium. Okay. Now we do see that it's an effect, but what we want to get at is what is the reason that this effect is coming from. Specifically, what we want to get at is the gain in the price due to the, sort of we're solving the exposure problem. So is it because of cost complementarity, or is it because more internet providers are now entering the market, right? So there can be sort of two effects, and to do sort of meaningful policy counterfactuals of how to sort of implement this on, other states and at a nation level, we would need to know these parameters. So that's our next step that we are working on. To do that, we're starting with setting up a model. So I'm just going to sort of show you guys simulation, and we have sort of few ideas to how to do the structural estimation. And so to do the simulation, we're sort of looking at N internet providers, and W is the number of schools. And basically here what's happening is in the bundled auction, the winner is decided according to the sort of the capital BI, which is the average bid, right? So the average bid for all the schools that are part of the consortium. And then you would have a basic profit function that will be there according to the bid that you, the winning price that you get minus the cost that you have, and what is the probability of you winning the auction, right? One more detail that we have here is that this gamma factor reduces the overall cost for all the schools, and this captures the exposure effect or the cost complementarity, right? So if we capture the gamma effect, that was going to give us the cost complementarity in this function. We derive that there is exists a unique equilibrium to this auction game, right? Okay. Now, the problem here is that there is competition, right? So there'll be entry in this auction because you have bundled schools. But you'll also have cost complementarity. The cost complementarity, which is coming from this gamma factor, would in turn increase the probability that internet provider will enter, right? So these two things are sort of related to each other. And we want to sort of disentangle these two effects. Okay, so to start with, we're doing a simulation, and the two things that we're adding in the simulation is first, we're looking at schools, two types of schools. So we're looking at schools which are high and low cost type, right? Because the idea is within New Jersey, there were rural areas and urban areas. So rural areas were usually the areas where the network was slow. Most of the internet providers were not there. So those would be the high cost schools for the internet providers. And low cost schools will be the ones which are more in a dense, highly populated location where already most of the internet providers have their service, right? So we want to see how this higher low type school affects our results. And then we're going to also simulate across different gammas, so across how much is the cost complementarity, right? So the gamma was sort of different from 0.6 to 1, right? Remember, if it is 1, then there is no cost complementarity according to the cost function in equation 3. Okay, so these are the results that we have. So first, let's just look at, so here in this column, we're looking at what would be the result if it was a single auction, right? So if it's only the low cost school is asking for the price individually, high cost school is also asking for the price individually, and the bundle B1 is if you're combining the demand for both. What we see is the entry on average, it will be, of course, more for the low cost school than the high cost school, right? There'll be more sort of entrants to serve the low cost school than the high cost school. In fact, if we just look at bundling the demand without any cost complementarity, then we see that the entry is lower than the entry for the low cost school, right? So if there is no cost complementarity, then the internet providers would basically just want to serve the low cost school, right? They would not want to serve the high cost school or a bundle where they have to serve the high cost school. right? So without any cost complementarity, it seems that the low cost school has the best average cost, so the best sort of price that we get and the best entry results. Once we include the gamma, that is cost complementarity, we see for high gamma, for low gamma, which is high cost complementarity, the entries in fact higher in bundle, even if we compare it to the low cost school, right? So if you bundle the product and there is some cost complementarity, then the low and the high cost school both benefit from the bundle, right? So the idea is without the cost complementarity, in the bundle, the low cost school is sort of subsidizing the high cost, right? That's what's happening. But once we include the cost complementarity, we see in terms of average cost, the low cost as well as the high cost is benefiting. So if you see it's 1.18, which is less than even 1.34, which is the cost that the low cost school was getting, right? So there is an interaction between gamma, low cost and high cost. So that's what sort of our simulation, we're going to sort of run more simulation to see what happens if the percentage of high and low schools differ across regions. And the idea here is now to take this to an empirical model and estimate gamma and an entry option. Okay, so I have sort of more ideas I can talk offline of how we're trying to set that up empirically. In conclusion, what we see is that demand aggregation has similar effect to giving E-rate subsidies directly to schools, which is basically, okay, we're going to pay part of your cost of internet provider. We can actually use the sort of location-specific cost complementarity to increase entry and thereby decrease price. And once we set up the structure model, our hope is if we can isolate the effect of entry as well as cost complementarity, we can sort of do more counterfactuals to see what should be the optimal region that is divided. So if I go back to the first slide, these regions were arbitrarily decided by the New Jersey government, but we would also want to see what is the optimal division of these regions and how that will lead to a better gain in price. Okay, I think I'm out of time, but that's for it. Thank you.
Any questions?
Yeah.
The equilibrium was unique here, right?
Sorry?
The equilibrium of the model would be unique.
Oh, this one? Yeah, so this is just it'll have sort of a bit shading part, which would be similar to a first price auction. But I don't have this in this side. But the idea is that since we're sort of combining all the cost and the decision is made on the average bid, this will sort of boil down to the basic first price auction. Yeah. The tough part is the individual bids. They would have multiple equivalents, right? Because what you're considering is the overall bid for the winning internet provider, but the prices that schools actually get are the single bids that they sort of submit, right? So which bid would you submit for the low cost and the high cost, that has multiple equivalents.